In this video, I'll show you how to make an inventor model of the offset flange, and the sketch says offset flange SI, and that stands for International Standards. So what that tells us is that this model is in the increments of millimeters, right? So this is a metric model, and so if we look this thing over a little bit, we'll see that there is a cylinder here on the back that has a diameter of 200 millimeters and a thickness when we extrude it of 25.4 millimeters. And then we have a 100 millimeter diameter cylinder that connects between this back cylinder and the front cylinder. And the total thickness of this extrusion of all three of those is 100 millimeters. So we know that this one is 25.4. And if we look at the front cylinder, we see that it's 25.4. So the height of the extrusion for the middle piece in here would be 100 minus this 25.4 and minus this 25.4. Then when we look out here, we have a diameter of a cylinder that's 150 millimeters. And then on both cylinders, we have a pattern of holes, which we'll get into. So the important thing is that when we start modeling this is that we model this as a metric IPT and not an IPT that's in inches. Because if we do it in inches, then this would be, for example, 150 inches, which would be over 10 feet in diameter. All right, so I'm going to pull this over to the side and show you Inventor. And so what I'm going to do is go over to the button that says File, and then I'm going to choose New. And when the dialog box opens up, if you see right here where it says Standard IPT, that would not be the correct one to choose because, as I said, this needs to be a metric IPT. So if we look over here where it lists our templates and there's a little caret right here on the side, if you click on that, you'll see some options, and one is metric, and you can click on metric, and then you have several options in here, but across the top you have a standard millimeter, that's the two M's, IPT. Click on that and pick Create. And of course, then our sketch opens up as it normally would, and we would start, at least I would start, by projecting geometry, and I would project the the YZ plane onto my XY plane here, and I would project the XZ plane's intersection as well. So I have these two green lines there, and I can use those as geometry to create my part around. So I'm going to begin by drawing the back circle. So I would snap to my origin here, and I would want that to be 200. So I would type 200 for the diameter and press enter. And then I'll just go to my home view so we can kind of see it in that aspect right there. And I'm just going to type E and press enter, which would put me into extrude. And I have to pick the profiles, and you may have to pick all four quadrants here. And for the distance, you would type 25.4 and press enter. All right. We're going to do a sketch on this surface here, and this is where we're going to draw the circle that has a diameter of 100. And that circle, we can see its diameter of 100, and it's located straight down from the center 50 millimeters. All right. So I'm going to choose this front surface and then pick right here where it says Create Sketch. And I will draw another circle, and I'm just going to get on this line and sort of follow it down and just go somewhere down there and pick, and then come out here and type 100 and enter. Now what I want to do is put a dimension between the center here and the center there, and I want to make sure that this says 50 and enter. And when I do that, this circle here should be tangent with the bottom of this cylinder that we just did right there. So I'm going to finish that sketch and go to extrude. And for the extrusion distance right here, I'm going to type 100 because that's the total thickness of this part, minus, and then in parentheses, I'm going to say 25.4 plus 25.4, and then close the parentheses. So you can see 25 minus 100 minus 25.4 plus 25.4, and press enter. And so that is how thick this centerpiece is on that. So we're going to pick right here and start a new sketch. And at the center of that, we're going to draw a circle. I'm going to snap to that. And the diameter of this will be 150. So I type in 150 and press enter. And I can go to my home view so we can see what's going on over here. So I'm just going to type E, which put me into the extrude command. Oh, hang on. It looks like it drew a circle. There we go. Now I'm going to type E. And what I want to extrude this guy, the distance of that is going to be 25.4. And it should be defaulting to millimeters. If you see inches in here, you've got a problem. So you can always try to type millimeters if you need to. And then I'm going to pick OK. Now, just to show you something about this metric drawing here, if you go to Tools and you go to Document Settings and you look at your units, what you should see is that your links are in millimeters like this, okay? And I don't know if it'll show that anywhere else, but we do want to just, we can always check by going to Tools, Document Settings, and just confirming that everything is set to millimeters. And when you make the drawing for this, you can even check that, and you can make sure that says ANSI, A-N-S-I, and then mm for millimeters, if you want to check that same way by going to Tools and Document Settings when you get into your IDW in the drawing for this. All right, so we need a hole right here that is a counter bore, and the size of that hole is a diameter of 50. That's the smaller hole. It goes all the way through. Then we have a counter bore that has a diameter of 75. That's this larger bore we have right here, and that goes to a depth of 6.4. So what I would recommend on this one is just getting on 3D model and going straight to the hole tool, pick on hole, and pick on this surface like that, and then come out and pick on the edge of this, and what that will do, it will center that automatically right in the center of this right here. Now what we want is a simple hole, so we want this selected. We want a counter bore, which is what we have right here. And then down here you can see for some reason mine are defaulting to inches, but when I highlight that, if I say 75, that will be 75 millimeters. And my depth will be 6.4. And the diameter for the hole that goes all the way through is 50. All right, so I've got 75, 6.4 for the depth. That's my counter bore. And then the hole that goes all the way through is 50, and pick OK. And just to confirm that goes all the way through, if I click on, go to my view cube and click on front, I should be able to see through like that. All right, so now I'm going to place a pattern of holes, and these holes are, it says 5 times 19. That's the diameter. And so these holes, the 5 holes, fill the top 180 degrees, but they don't go all the way around. They just fill this top. And one of the things I know about Inventor models, when I use the circular pattern tool, that it patterns in a counterclockwise direction. I mean, that's the normal direction for it. So what I'm going to do is draw this hole here first. I'm going to place that hole with a diameter of 19, and then I'm going to use the circular pattern, and I'm going to create 5 copies of that, and I'll want that to fill 180 degrees, so it will only go around the top half of my part. Okay, so here's how I'm going to do that one. I'm going to go to, I'm going to actually pick on this surface and go to Create Sketch. because I'm going to use the point center point tool. And remember, if you place a point center point, then you can construct a hole where the center of the point center point is. So I'm going to pick on that, and I want to just make sure that I'm snapping right on this line, so I could go to the midpoint or to the center point if I want and kind of acquire that, follow it down that line, and just pick someplace like that. Now hopefully I'm right on that line. And so I'm going to put a dimension on there, and I'm going to go from the center of that to the center of my entire part, which should be right in there. And I'm going to bring this up here now. That is supposed to be 75, the radius according to the sketch. So right here I want to edit this dimension and make it 75 and pick OK like that. So hopefully my point center point is on this line. If it's not, I would have to dimension it between the center point for this larger cylinder and the center of that. But I think it's on there. It just looks a little bit funny, but that's okay. I'm going to finish the sketch. And so now I'll go to the hole command, and it will pick that automatically. And what I want to do I want to take off this counter bore, so I'm going to click right there. So all I want is a simple hole with no counter bore or anything. I want it to go through all, and the diameter should be 19, and pick OK. The next thing I want to do is make a pattern. I'm going to use the circular pattern tool right up here. Pick on that, and it asks me to select the features. You can see that button right there is blue, so I can come here and pick on this feature, or I can go over here to my browser and pick on hole 2. Either one will work. And so I've selected that. The next thing I need to select is the rotation axis, and that would be the center actually of this 200 millimeter in diameter cylinder that I have right here. So I'm going to pick on this button there, and I'm just going to pick on the outside edge of the cylinder. And when I do that, it locates the center axis of that. And then it asks me for how many of these do I want under placement, and it says 6. That's the default, but I actually want 5, so I'm going to type 5 in there. And I don't want to go 360 degrees. I'm going to highlight this and type 180. And you can see the arrows pointing in a counterclockwise direction right there. And at that point, I'm just going to choose OK. And it should build those holes. And so if we go look at those, that's what that should look like. Now I'm going to go back to my home view. So the next thing I need is a pattern of 5 holes that go all the way around this flange right up here at the front. And those holes are, let's see, 9.5 millimeters in diameter. There are 5 of those, and they are placed around a bolt pattern that has a diameter of 125 millimeters. And if I look at these holes, I would see that none of these 4 holes that I'm pointing at here lie on a horizontal or vertical axes, but this hole right up here at the top does lie on the y-axis, directly above the center mark right there. So I'm going to build this one first, and then I'm going to pattern the rest of them using the dimensions that I have in here. Okay, so let me drag this over. So I'm going to start a new sketch right here, and what I want to do is place a point center point again. So I'm going to pick on point, and I want to just put it along this y-axis. So I want to make sure, you know, if I move my cursor on here, that I actually am kind of snapping onto the y-axis. I'm not sure where I want to put it. I just know I want to put it on there, so I'm just going to pick. That should get it on the y-axis like that. And as I said, that bolt pattern is 125 millimeters in diameter. So I'm going to place a dimension, and this one is a little tricky because I want a dimension from the center of this up to that point center point, and I want that to be half of 125. And if you come down here and try to pick on this center, because it's not the actual center of the part, that's the origin is up here, you can't locate it. But what you can do is go to the edge of this cylinder right here and pick on that. And that will grab the center of that and then come up here and pick on the point center point and then drag that out like that. Now, I said the diameter of that bolt pattern is 125, and I need half of that. So I can actually type 125 divided by 2 and then press enter. And that should put that in at 62.5 from this center right here. I can finish the sketch now and go to hole, and I want a simple hole, and I don't want it to go through all. I want it to go to, and I want it to go to the next level here. So I'm going to go to my view cube and I'm going to pick on that corner right up there. And I'm actually going to pick this edge back there. That's how far I want this hole to go through. And then I'm going to choose this. So it's going to the next plane that it hits after it goes through here. So that's just going to be 25.4. And the diameter of that hole needs to be 9.5. And it's a simple hole. It's not counterbore. It goes to the next plane. 9.5 is the diameter. So I should be able to just pick OK, and it should create that hole for me. So you can see there's that hole. And the hole does not go through this piece back here. That would be too deep if it did. So I'm going to use circular pattern again. And it wants me to select the feature, which would be this hole. So I'm going to pick on that hole or pick it from the tree over here. For the rotation axis, I would pick on this button. And I'm going to pick on the edge of this cylinder. So that selects the center of the cylinder, the center axis of the cylinder. Then I'm going to come right up here and I want 5 holes. And this time I do want to fill the full 360 degrees, so I would pick OK. And if we look at that, that is what our part should look like after we do all of that. And so I'm going to drag this back over here. And it looks like we have everything we need to model this part now. So I believe our part is finished, so we would just want to come up here and do a save or a save as, and save this as offset flange. You can name it offset flange SI. Remember, that stands for International Standards. And the reason why the S comes before the I is because it's actually a French term that says Standards Internationale. Okay, and that stands for International Standards. And at that point, I think we're finished with this. So the next thing we're going to do is open up a prototype drawing, an IDW, that is also set for metric units. And we're going to place the front view of this object and the right side view, and we're going to scale those to an appropriate scale, and then we're going to place all of the dimensions on these views that we see in the sketch. Okay, so that ends this video for now.